Assalamu alaikum. Hope you are doing fine. In my previous video, I used one galvanometer to show the induced current in a coil due to change in the magnetic flux. Galvanometers are usually used to measure the current, and they are also used to find the direction in which the current flow. This is the galvanometer used by me in the last video. It can measure the current, and also it can show the direction in which the current flow. This kind of galvanometer is called as moving coil galvanometer. In today's video, we will learn about one more type of galvanometer called as tangent galvanometer. Tangent galvanometers are used to measure even a small current flowing in circuit. This device is known as tangent galvanometer. It is a kind of moving magnet galvanometer. In this device, when you use this to measure current, the magnet moves. So it is called as moving magnet galvanometer. It works on the principle of tangent law. Tangent law says that when a magnet or magnetic needle suspended freely in two mutually perpendicular magnetic fields, it aligns itself in a resultant of these two fields. We call it as the tangent law. Now, if you look at the construction, it consists of a circular frame made of some kind of non-magnetic material such as brass, wood, or even plastic. This vertical circular frame consists of several turns of, or currently speaking, it consists of turns of enameled copper wire wound on this. Usually, the tangent galvanometer that we use in the lab have three different turns of coil. It is obvious from here. If you look at this, it consists of four knobs. Number 2 is written here between these two knobs. That shows that starting from here till this knob, two turns of enameled copper wire runs through this circular frame. And here number 50 shows that between these two knobs 50 turns of enameled copper wire of different thickness runs over or wounded over this circular frame. And number 500 shows that between these two knobs enameled copper wire of 500 turns is wound on this circular frame. If you connect the circuit to this tangent galvanometer using these two knobs, that means you are passing current through two turns of wire. Here, these three turns of enameled copper wire have different thickness, and they are used to measure current of various intensity. Now, this circular frame, as you can see here, is placed on a base. This base is a kind of a turntable. It can rotate in this manner. It is provided with three leveling screws. They can be adjusted to make the instrument exactly plane. It can be shaped with the help of a split level. Now remove this. Here you can see an upright projection. This upright projection is to hold this magnetic compass. It is used to hold this magnetic compass, which is otherwise known as magnetometer box. Now, is placed in this manner. Now, if you look at this magnetic compass, you may find it consists of a small magnetic needle. It is made very small, such that when it is placed here, it can come within a uniform magnetic field produced by passing current through this coil. And here there is an aluminum pointer mounted perpendicular to this magnetic needle. This magnetic needle is pivoted on a sharp edge like this. Here I have a sharp pin. If I place this magnetic needle in this manner, I can say that I have pivoted this magnetic needle on this sharp pin. I hope you would have understood what is the meaning of pivoted. Now, very important thing you need to know about this compass. This compass has got a circular graduated scale. It has got a circular graduated scale which has got 4 quadrants, divided into 4 quadrants. 0 to 90 is one quadrant. From here 0 to 90 is second quadrant. 0 to 90 third quadrant. Again 0 to 90. Here it's the fourth quadrant. On this circular scale, the aluminum pointer move. This is how we measure the angle to which it has moved while reading the current. And one more thing, if you look at the back side, the bottom of this aluminum pointer, you may find a plane mirror. This plane mirror is used here to avoid parallax error while taking the reading. Now place it here. Now I will tell you what are the precautions to be taken while using this instrument. The first precaution we need to take is we should avoid the presence of any kind of magnetic material around this instrument. It's highly sensitive. If there is any magnet or magnetic material around this around the vicinity of this instrument, it will malfunction. So we need to avoid the magnetic materials from the surrounding. Second thing, the coil, the vertical coil, should be adjusted and placed in such a way that it exactly come above this small magnetic needle. Third, rotate this magnetic compass such that the aluminum pointer reads 0, 0. And next thing, level the screws such that when you place a split level on the compass, the bubble in the split level should be at the center. So level it in this way. See, the level, the bubble has come to the center. This shows that the compass is kept exactly perpendicular, or exactly parallel to the surface. Otherwise, what will happen? If it is not plane, then the aluminum pointer will touch the circular scale and it will not show the exact reading. I hope this video is useful. If you have any kind of doubt related to the topic, kindly put your questions in the comment section. Thanks for watching.